this is problem 3 from the homework. And of course, where we're always going to start is by balancing the equation. And it looks like it's all balanced. Wonderful. Okay, so we have 560 milligrams of magnesium iodide and 360 grams of bromine. And the first question asks, which is the excess reactant? So what we really need to know is how many moles of magnesium iodide I have and how many moles of bromine that I have. Okay, so we'll start with the magnesium iodide. I have 560 grams magnesium iodide. Okay, and I'm trying to convert grams to moles, so the correct conversion factor would be molar mass. And I need grams down here. And the molar mass of magnesium iodide is 278.114 grams magnesium iodide per 1 mole magnesium iodide. Okay, and that equals 2.01 moles magnesium iodide. Okay, and I have 360 grams Br2. And again, trying to go from grams to moles, so the correct conversion is molar mass. The molar mass of bromine is 159.808 grams bromine, or 1 mole bromine. And that equals 2.25 moles Br2. Okay, and since these are on a 1-to-1 mole ratio, it's pretty clear to see that magnesium iodide is going to be our limiting, and Br2 is going to be our excess. Okay. Now this is actually pretty interesting. This happens sometimes, and this is why you have to actually do the math. Although there is a much higher mass of magnesium iodide, there are actually fewer moles. So you need to calculate out. You need to find the number of moles to make sure that you have the correct mole ratios and conversions. Okay. And then the question also asks this: what mass remains? And that's a tougher question. And what you have to do is you have to find the mass of bromine that you actually use and then subtract from the mass that you start with. So there are several different ways that you could do this. You have the moles of bromine, and you know how many moles of bromine you're going to use because it's a 1-to-1 ratio. So you could subtract and convert back to bromine. But what I chose to do is go all the way from the start. So I want grams of Br2 given 2.01 moles MgI2. Okay. And the first thing that I see is magnesium iodide is not bromine, so I know I need to use a mole ratio, and in order to use mole ratio, I have to have moles, which I have. So I can do 1 mole MgI2 over 1 mole Br2. Okay, and I in fact want grams, so I need to convert moles to grams using molar mass. 159.808 grams Br2. And 1 mole Br2. The moles Br2 go away, and I'm left with grams of Br2, which is what I'm looking for. And I get 321.8 0.784 grams Br2 used. Okay. So I'm going to get myself a little bit more space here. Okay, now the amount of Br2 left is going to be what we started with minus this. Easy enough, right? So the leftovers are 360 grams Br2 minus 321.784 grams Br2. And that gets me, with sig figs, because there are only 2 in this problem, 38 grams Br2 left over. Okay, so there's my answer to part A. Yay! And B, let's go back up to B. B asks you what mass of I2 is formed in the same process. So you still have to do all your calculations based off the limiting, but you want grams of I2 using 2.01 moles MgI2. That is not a very good looking I understand, but we will power through using our mole ratio to convert from moles of magnesium iodide to moles of iodine. Those are gone. And I still need to get to grams. Of course, the conversion factor here is going to be molar mass. 253.809 grams I2 over 1 mole I2. And you get, with sig figs, because there are only 2, 510 grams I2. There you go.